Now in this session, we'll study a bit about normality test. If you remember, one of the key assumptions of hypothesis in that we use in hypothesis testing is that the error term follows a normal distribution. Okay, and so it's important to really understand if the residual term in this linear regression model genuinely follows a normal distribution or not. And remember that we never observe the population regression function. That is, we never observe uh, the UIs. Instead, what we observe are the EIs, the residuals. Okay, so we basically study the residuals in these normality test, and there are three ways to test normality. One is by means of histogram of residuals, normal probability plot, and the Jag Beta test. Let's start with three or the one of the three. So in the first one, we will look at the histogram of residuals, and on the x-axis, as we can see, we have basically plotted the residuals, and if you notice, we have basically divided these residuals in small intervals. So in a sense that it's more like a bar chart, but we then try to superimpose a normal, basically a curve, a normal distribution of it, and we see how fairly it represents how fairly this histogram it represents this normal distribution, and in this case it indeed is representing it pretty well. So the idea is that the frequency distribution of this residual should be approximate normal. Okay. The second one is the normal probability plot. This is another graphical method. On x-axis, we plot the residuals, and on y-axis we have the percentage. You can say probability basically. And if you notice, now if population indeed were normal, then the normal probability plot will be a straight line, or will be approximately a straight line. So you can see there's a straight line here, and the residuals are very close to this straight line, except this one residual, which of course is an outlier in the distribution. So since they are very close to this red line, we can say that indeed the population were the error term is somewhat normal. Okay, but the most, I would say, the most frequently used test here is the Jag Beta test. It's a large sample that is asymptotic test on OLS residuals, and we first define the null and alternate hypothesis. So the null is that the residuals come from a normal distribution, and naturally the alternate hypothesis will be that residuals do not come from a normal distribution. Okay. Now we construct the test statistic, which is your JB test or the Jag Beta test. It says n by 6 times s square plus k minus 3 whole square upon 4, where s, this term s, is the skewness of the distribution of the skewness of the residual term. Okay, and k is the kurtosis, and n is the sample size. So if you recall from your basics, that the any normally distributed random variable will have skewness equal to 0, k equal to 3. This is incorrect. K should be equal to 3 here, and if you put 0 here and k equal to 3 here, then you will get JB equal to 0. Okay, so naturally a large values of JB statistic imply a departure from normal distribution. So if you get let's say you're getting skewness +1 or -1, or in this case you're getting kurtosis +4, let's say +4 or -4, that is any number basically, but not 3. Okay, so in that case the JB statistic will assume a really high values, and this statistic basically follows a chi-square distribution with 2 degrees of freedom, and naturally if your calculated chi-square value is greater than the critical value of chi-square distribution, we reject the null hypothesis. Okay,